Hello, everybody. So this experiment is about Snell's law and, of course, the law of reflection. So what you see here is a laser beam that enters at 30 degrees and leaves at 30 degrees, so it is just straight propagation of light. However, now we are going to place in an optical surface that is basically indicated by this flat area here. So when I put the optical surface in here, then of course two things happen. One thing is we get a reflected beam and we get a refracted beam. And you see now that, as expected, the reflected beam leaves at precisely the same angle as it enters with respect to the normal to the surface. However, the refracted beam leaves at a different angle than it enters. So this is described by Snell's law. And there's another interesting aspect on Snell's law, which predicts that when we change the input angle here, then there's a particular angle, which is about here, where we do not get any transmitted beam anymore. So here we are at what is called the critical angle, and that is at an input angle of 42 degrees for this particular material. So from both of these things, the 42 degrees angle or the exit angle when we were at 30 degrees, so if I put this back to 30 degrees, like this here, you see that we are leaving the material at 48 degrees here. So from both of this, you can work out the index of refraction of this material as described by Snell's law.